A researcher at Walter Reed Army Institute for Research holds a sample being tested for superbugs. Maggie Fox, NBC News, NBC News. It is an extremely rare gene. How it got on this farm, we don't know, said Thomas Whittam, chair of the veterinary medicine team at The Ohio State University, who led the study team. The gene is called BLAIMP27 and it gives bacteria the ability to resist the effects of a class of antibiotics called carbapenems. Carbapenems are considered an antibiotic of last resort, so germs that resist their effects are very difficult to kill. Worse, this superbug gene is carried on an easily swapped bit of genetic material called a plasmid, and the researchers found it in several different species of bacteria on the farm. That suggests the bacteria have been passing the gene around. Related. The worry is that the gene will get into bacteria that infect people, a type of antibiotic-resistant germ called. Just this summer, researchers sounded the alarm about a drug-resistant E. coli sample carrying a gene called MCR1. It was also carried on a plasmid, and the fear is such an E. coli bacteria with the MCR1 gene could pass it to another superbug with other mutations, creating a truly superbug that resists all known antibiotics. Something similar could potentially happen with the BLAIMP27 gene found at the pig farm. Whittam and his team had been checking samples submitted to testing labs from pigs suspected of carrying bad infections, and from a few samples sent from farms. The BLAIMP27 turned up in a single farm sample, Whittam said. He turned his team loose to test the farm. They moved in with Swaps and Swiffers. The Swiffers are just like the household cleaning took, Whittam said. They're electrostatic, so they are good for taking samples, he told NBC News. Related. They swabbed pigs, took fecal samples, tested pens, fences and equipment. I stayed here in my office and did important supervisory and coordination work while the grad students went out and collected poop samples, Whittam said. The farm was a moderate-sized, family-run operation, Whittam said. He declined to identify it any further than that. It has 1,500 sows and raises the pigs from pregnancy to sale for slaughter. They made multiple visits last year to the farm, where the sows give birth in tight pens and the piglets are taken to separate pens of 25 each after they are weaned. They found samples of the BLAIMP27 gene in several different samples and in several different species of bacteria, including E. coli and Enterobacteriaceae. Several of the bacteria found resisted more than one type of antibiotic. They were also found in some of the sows and piglets. Although the animals appeared to have cleared the germs, none were found in pigs ready for slaughter, although the team is watching for them. But it's bad news to find this rare superbug gene in bacteria infecting food animals, Whittam said. The implication of our finding is that there is a real risk that CRE may disseminate in food animal populations and eventually contaminate fresh retail meat products, the researchers wrote. Even if it doesn't make people sick right away, it could colonize people who handle the raw meat. Colonization means people, or animals, carry a germ but don't get sick from it, but if they do become ill with something else, the bacteria can multiply. Plus, colonized people can infect sick or frail people. The emergence of carbapenem-resistant Enterobacteriaceae, CRE, has been described as heralding the end of the antibiotic era, with their global expansion presenting an urgent threat to public health, the researchers wrote. These potential pathogens can harbor highly mobile genes that confer resistance to the most critically important, life-saving antimicrobial drugs. Related. It's also worrying that the farmer has no idea where the germ came from. This operation has been managed as a closed herd since the 1960s, the researchers wrote. We think it was carried in, Whittam added. We don't know if it was on equipment or supplies or by people. Whittam says the pigs never were given any carbapenem drugs and they were not dosed with antibiotics to promote their growth, a common but increasingly condemned practice known to contribute to the rise of antibiotic resistance. But they do get antibiotics. As is common in U.S. swine production, piglets on this farm receive ceftiofur at birth, with males receiving a second dose at castration, the team noted. This routine dosing may be helping drive the development of mutant bacteria, Whittam said. We may need to examine some of the practices of farms, and evaluate whether they are really appropriate, and whether the benefits outweigh the risks, he added. To save our miracle drugs, we have got to stop wasting them on animals that aren't sick, said Dr. David Wallinga of the Natural Resources Defense Council, which opposes the routine agricultural use of antibiotics. The last terrible shoe may have just dropped when it comes to drug-resistant infections. This is just one more warning that doctors may soon have nothing left in their toolkit to save patients when these bugs strike.